So let's go through these exit ticket questions here. Now the first one, they're giving you a square, but they're not giving you a side measurement. Because if you had a side measurement, a square being a rectangle, which is also a parallelogram, there's things you can do, formula-wise to find the area of it. But they're giving us essentially what the radius of the square is, the distance to the corner here. Now, the thing I have to keep in mind about this, using some of the methods that we're learning about, and of course technology sometimes not cooperating. Give me 1 second here. Let's try that again. So this triangle down here, knowing some information about it will certainly help me figure out, some things about this. If I have all those triangles together, the four angles in the center would be, totaling 360, which means that angle in that triangle, the central angle, is 90 degrees or a right angle. And we essentially now know that these two sides are 8. That makes it a 45, 45, 90 triangle. And a lot of the circumstances you're going to face are going to, I would say more oftentimes be involving special right triangles. But if they don't, you can still make use of trigonometric functions to help figure out some of the additional information. But, using my ratios, I know that the side of the bottom here, the base, would have to be 8 times the square root of 2, because that's the hypotenuse of this right triangle. Now, I don't have to go through and use any of the special formulas from this particular lesson, because I now know that this is the side of the square. And so I'm just going to basically use the base times height, because I know, like on a square, this is also going to be 8 square root of 2. So when I do the length times the width, or the base times the height, whichever way you want to consider it, I'm just going to multiply those two together, and I get 128 square millimeters. Remember, when you deal with, don't know why it disappeared. When you deal with area, it's always going to be in units squared, so make sure that you're aware of that. For the next one, now you're given a hexagon. Now, as I mentioned before with the hexagon, and I'm just going to make sure things don't run together here, so I'm going to change the color of the ink on this. I have all these triangles that are formed from the center. You still have to be aware of those, because you need to know the central angle to figure out, because we're looking at that bottom triangle, and what they're actually giving us is the height of that triangle, which they're saying is 16 times the square root of 3. Let me get that erased. Inches. But also I'm knowing that this entire angle here is 60 degrees, because I have 6 of those angles, in the center, each one equal to each other and totaling 360. And, I don't know what the sides of the radii are, but I know, like, each one of these sides here, which I'll call, just for the time being, x, x, and x, are all going to be the same. The triangles, though, that, that the apothem creates is essentially, I don't want that other part. Well, let's deal with it. Focusing on this one here, this is 16 square root 3. This angle down here would be 60, because it's actually an equilateral triangle at that point, and I'm dealing with a 30, 60, 90 triangle. With the 30, 60, 90 triangle, I know that, the side opposite the 60-degree angle is the shortest side times the square root of 3. That means that the shortest side, S, should equal 16. Well, I have to remember that shortest side, S, is, half of the total length. So each side is 32, inches. Now I'm going to erase some of this stuff because some of the other graphics are going to come in. So I do know I have a 32-inch side. I know I have an apothem that's 16 times the square root of 3 inches. I can now use the formula that the area of a polygon is 1/2 the apothem times the perimeter. Because if I know the side length, I can figure out the perimeter. Or I could just say, basically, I'm going to do 1/2 the base times the height of that triangle, because the base is the 32-inch side. The height is a 16 square root of 3 inches. And then multiply that by 6. I would get the same results. So just erase some of this extra stuff down here because the work is going to show up down here. In a lot of situations, they do give you involve the special right triangle. So the side is 32 inches. If I use the formula, whether it's the 1/2 apothem times perimeter, or if I just find the area of the triangle and multiply by 6, I would end up with 150, the 1500 36 square times square root of 3 square inches. You can't enter that into the Google form. This one said leave in simplest radical form, but so if that's the directions you have, then that's what you would leave it. But this one here, though, says on the directions you're given in the Google Doc, you're to round to 2 decimal places, so that's what you would get here. And again, square inches would be your units. That's all I have. If you have any further questions, please ask your teacher or me until I get to see you in another live lesson, or if you're one of my students, I get to call you. Have a good day.